All right, so we've been going through data types. They should be pretty easy to distinguish. Ints and longs are integer types, no decimals. Floats and doubles are floating point types. They have decimals. The weirdness about floating point types is that they can get rounding errors even if the math doesn't look like it's going to get rounding errors. So if you're doing something that's only going to deal with whole numbers, like you just have a counter ticking off 1, 2, 3, and 4, you may as well make it an int. If you do need floating point, go ahead and make it a long, as it's the default data type. Default floating point data type for Java. Escape sequences. We've seen these already. I don't know if I've talked about them all, but /n means go to the next column. No, it doesn't. It means go to the first column in the next line. It's just like hitting enter on a key. /n. /t moves to the next tab spot. Stop. So we could print out somebody's name and then type in a /t and then print out their last name, and there'd be some spaces between it. And you could try to make columns, try to make your output look pretty with /t's. There are better ways to do it. Then there are double quotes. Have I talked about this? Okay. There is the escape sequence for double quotes, there's the escape sequence for single quotes, and there's the escape sequence for printing a backslash. And let's think about why we might need those. Escape sequences don't really mean a darn thing until you're trying to print the data. But then they do mean something very specific. And they have major impact on how the data is processed. So let's give an example of using them correctly, or at least /n and maybe /t. System.out.println. My name is /t, Joe /t, nameth. Don't know why I felt like saying that. Okay. Except I'm just going to use print rather than print ln. And then after the ln, the /n, don't know where I'm coming up with ln, after the /n, we're going to print something else. Isn't that cool? Okay. So when this prints out, what it's going to do is my name is, it's going to hit the tab key, then it's going to print out the word Joe, and it's going to print out the tab key, and then it's going to print nameth. Isn't that cool? Now that's kind of dumb. I'm going to take that message off, but we're going to put another one on. Your name is Bob Roberts. Now, if we're lucky, these /t's will line up the output. And what do I mean lucky? Well, if you never really know what tabs. But in this case, it did work. Kind of lined them up in columns. That's what you would use tabs for. The problem is that if your data is larger than a tab in the output, which I believe is 8 spaces, then your columns get totally out of whack. So there are better ways of dealing with making columns of data than that. Okay, so data, let's make a string. And let's do this. Data is equal to my name is Slim Shady. And we're going to put quotes around it because that's obviously a nickname. Hopefully his mother didn't name him that. Here we go. Oh, that's a compilation error. Why is that? What's wrong with it? Yeah, we hit this end quote here, so it looks like this is a string, and then it thinks that this is, actual programming code. And obviously that's not actual programming code. So in order to get that to print out, we have to tell it that, oh, that quote's not really a quote. There we go. It's not a quote as far as the compiler is concerned. It is a quote as far as output is concerned. So when it's being printed, what's going on is it goes, my name is, or when it's being compiled, it hits the quote and then it goes, okay, all of this is part of the string. Then it hits the backslash and it escapes into a different mode. That's why it's called an escape sequence. And in this mode, the character that follows the escape sequence does not end the string. So it keeps going. Slim Shady, and then it finds another backslash. And again, it escapes into another mode that says that the character that follows a backslash is a special character and it doesn't terminate the end of the string. And that way we don't get any errors from that. And when these print, backslash quotes just turn into quotes. Like that. And although not strictly necessary, your name is the Frisco Kid. That doesn't give us a compilation error. But you can still use escape sequences there. Why would you need to do that? Well, what if you wanted to make a single character that held a quote? A single quote. Let's call it apostrophe. Now, single quotes, when you give them data, characters, when you assign them data, the literal has to be surrounded by single quotes. It has to be surrounded by apostrophes. But what if we wanted to make that apostrophe character a quote, a single quote? Now we get an error. Same reason. It thinks that's the opening of the characters, and then it thinks that that's the closing of the character, and it doesn't know what's going on. So you can put a backslash there. That tells the compiler, oh, by the way, this is really a special character. It's not a quote that ends the string. It's not a quote that ends the character. And then when it's printed out, that is turned into a single apostrophe. Another case where you could see something like that being useful is what if we had this. And then we printed it out. Guess what it's going to look like? It's not going to look pretty at all. File to, let's make it even look nicer. File to open is equal to, let's put single quotes around it to make it look so cool. There we go. Looks like a good print statement. It didn't cause a compilation error, but when we print it, we get this. File to open is equal to C:, file able.txt. So what's going on there? Why did the output get so garbled? Yeah, there's a /n right there, and that's being treated as a new line, so it's going back to the first column. Whoops, so it leaves out the n. And then there's a /t there, which gets hit as a tab. Now it doesn't look like much of a tab, it's only one space, but that's because tabs are kind of weird. So anyways, if we wanted to make this look pretty, you could do that. Because // is another escape character that, when it prints, gets converted into a single slash. It's an escape sequence as well. The first backslash says, oops, we're going into a different mode now. That mode is that this is a special escape sequence, so the next character tells me what I really am. And then the second slash is, oh, no, I guess I was just kidding. I really am just a mere backslash. And so when we print it out, those get converted into single backslashes. So we have 3 escape sequences of note, really. No, 4. /n, let's select the most important. /t for tab. I guess there's actually 5. /double quote, /single quote, and //. And there are other ones. There's one that stands for backspace. I forget if it's B or not. Let's see if it is. So if we started to type I hate, and then we felt guilty about saying I hate Java, so we decided we actually want to make it say I love Java, we backspace over that. Backspace 5 times so that we can type love. And then when we run it, it prints I love Java. Now you can't see it backspace, but like in the old days when these things actually, you know, you had letters appearing in slow motion on the screen like they do in movies, you know, with little tick, 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 tick sounds whenever they show it on a computer display, then you could see the backspacing. But, you know, in real life, you know, things happen lightning fast and we can't see the backspacing. There's no real reason ever to use that. There's another one that's supposed to ring the buzzer that's in your computer. It's supposed to go beep, and I forget what that is. I think it's /G, and I don't think it works in Java. Let's tack on a /G and see if it does. Whoops. No. Okay. I got a compilation error as soon as I tacked it on. So there's our 5 backslashes, escape sequences of note. Primitive variables versus reference variables. The primitive data types are the ones that start with lowercase letters. And there's really only a certain number of them. Int, long, float, double, char. I think they left out byte. All of those are the primitive data types. Those are built in to the Java language. So int, long, float, double, bool, char, excuse me, it's boolean, character, and byte are all lowercase letters. These are all primitive data types. That means that they are not classes. They don't have a lot of special methods hooked up to them. So if you start typing int, you can't type int dot and then get a list of methods involved. Whereas other things like strings, these are classes. You can type string and then hit the dot and you get a whole bunch of functions that can be used as part of the string class. So you have your primitive data types, which are just like the pure numbers that define the language, ints, long, floats, doubles, booleans, chars, and bytes. And then you have what are known as reference types. I don't really like the word reference type. I think of them as classes. These, because that's how you define them, with the class keyword. The classes are the ones that can hold more than just a single value. You could define a class that consists of a first name, a last name, and an age. So it's got all sorts of different data bits in it. It's not just a simple data type. It's a complex data type. It's called a reference type because when you create a variable of that type, it doesn't have any data in it yet. It's just a reference that could hold an object of that type. And that sounds a little bit abstract, but for now, remember that all reference types start with an uppercase letter, if you name yours correctly. That's pretty much a convention that all Java programmers follow. So if you see the word string, you know that string is not a primitive data type. String is a reference type. It's a class. S is a reference to a string object, which means that it does have members. So if I declare int I is equal to 0, and then I try to do something special with I, and I type I dot, no, that doesn't pop up anything. System, on the other hand, is a class. It's a reference type. It started with an uppercase letter. So when we type system, we see a whole bunch of members of this class, a whole bunch of different functions and constants that are associated with it. String, although we use it so often it seems like a primitive data type, really isn't. And it's got a whole bunch of methods in it. You can find out the length of the string, you can turn it into a series of bytes, you can find parts of it, you can split it, you can extract individual parts of it. I don't even know what weight means. How could you weight on a string? Anyways, so you can see that the string class, although usually we just use it to store a series of characters, is actually very complex. it actually contains a lot of different functionality in it. So it is a reference data type because it refers to an object of that class. So right now, S is a string reference, but it's not pointing to anything. And then if I say hello, like that, now it's pointing to some actual data. It's referencing that data. You could create two references that point to the same data. This is kind of deceptive. If you did this with integers, it would copy the data that was in the first integer into the second one. But this does not copy the word hello into B. Instead, they both now just point to the same data. You have two references to the same place in memory. Just like if you pull up your house on Apple Maps and then you pull up your house on Google Maps, it doesn't mean you suddenly own two houses. You just have two references to the same house. Or if you have a street that's got two street signs, you know, one on one end and one on the other, you don't have two streets. You have two signs referencing the same street. Here we have two variables referencing the same data. And that's why they're called reference types. They refer to data. They don't actually contain the data. The data is contained out in a storage area called the heap. And we will talk more about that. That's where all the objects are allocated. Now so far we've only dealt with a few reference types. Offhand, besides using system.out.println and system being a type, but we don't declare a variable of type system, so we're going to kind of ignore that. The only reference types we have used are string and scanner, because we did create a scanner in order to read our input. We did scanner, SC or IN, whatever you wanted to call it, is equal to new scanner system.in. That created a reference to a scanner object. The new keyword created that scanner object, and so now that reference points to an actual object which can be used. I'm going to add an import for that. So we can tell that scanner is a reference type, not a primitive data type, because it starts with a capital letter. And now if we type SC dot, we get a list of a whole bunch of different things that that data type can do, that class can do. So reference type is kind of synonymous with the term class. So let's make some notes here. String S, scanner SC. Both of these are reference types. String A is equal to hello. String B is equal to A. This does not copy the contents of that string into B. Instead, now we have two pointers, two references referring to the same memory address. And with strings like this, that's not really important. If you printed B out, it would still print hello. But that's because they're both pointing to the same reference. If you want to compare strings, you cannot just do if A is equal to B, like you can with numbers. If you do this, int x comma y, x is equal to 3, y is equal to 3, if x is equal to y, then print, wow, they're the same. That would work, because x contains the data 3 and y contains the data 3. Or if we say x is equal to 3 and y is equal to 2 plus 1, they'll print that they are the same. But if we do this, string A is equal to John, and then we do string B is equal to J plus OHN, we think that they're the same. But if we do this, if A is equal to B, print, wow, they are the same. They're not, because they don't point to the same memory. And that's all this comparison does, is to see if they point to the same memory. So even if those memory addresses contain the same data, because they will once these two things get added, they're not the same memory address. So this will fail, even though we expected it to be the same. If we printed A out, it would print John. If we printed B out, it would print John. Let's prove that. We'll go up here. String A. A is equal to John. B is equal to J plus OHN. Now let's print them both out. System.out.println A. System.out.println B. And then let's see if they are the same. If A is equal to B, system.out.println, they are the same. Else print, they are not the same. Now the acid test, let's run it. Oh, you lying. The compiler did some optimizing. It did some sneaky optimizing and figured out that, thanks. Okay, now I'm trying to trick it. A is equal to the string containing 1. B is equal to a string that contains the number 1 converted to a string. Hopefully it is not making a point to the same memory address now. So even though they run and they both print out as being 1 and 1, it says they are not the same. And we could do the same thing if we just asked ourselves to enter two values. That might even be a better test. System.out.println, enter a word, and then A is equal to scanner.next. We'll get that string, and then we will ask enter a second word, and then we will read that in. Enter a word. John. Enter a second word. John. They look the same, but they're not. Okay, so from now on, that's going to be my example. The other one didn't work. But you get the idea, because these are referring to different areas in memory. We have two strings now. We have one string containing the word John. We have another string containing the word John. So if you're going to compare strings, you cannot do it that way. That is not how you compare strings. You use dot equals. So if A dot equals B, then you print they are the same. Let me just copy these statements. And so the second time it prints something, it's going to be correct. As long as I really do enter the same word twice. John, John. We printed out John, John. The flawed comparison said they are not the same, but the good comparison said they are the same. So when you're comparing reference types, unless you really just mean to see if they both contain the same memory address, you can't just do equals equals. That will not work. So you cannot use equal equal to compare strings and other reference types the way you can with check this out. It's even warning us. This editor is so smart, it put a little warning here. The warning is comparing strings using equal equal. And it's offering to use dot equals. Now it expanded that to be horrible. But I guess it actually works. I see what they're doing there. Yeah, so it worked. They're just making sure that neither string is null. And why would a string be null? What if we didn't ever give it a value? What if we commented this out so string A never had any data in it at all? Well, the truth is that it's going to give me so many compilation errors that I'm never going to be able to demonstrate what would happen there. Okay, but if for some reason B was equal to null and we came down here, this particular comparison would still work, whereas this one would blow up. But that's not going to happen. So I'm going to delete that. Well, I'm going to undo that change. I'm just kind of making note of the comment that check the warnings. And sometimes the warnings offer changes that are useful. And sometimes warnings make the code absolutely horrible if you accept its suggestion. Not that we're using arrays yet, but I'm going to show you an array declaration. We're going to define an array. An array is a list. Parisa has used lists in Python, so this will look very familiar. And the only reason I'm doing this now, besides just giving you a sneak preview of what an array looks like, is to show you that the warnings are not all that. Now this is perfectly hunky-dory good code. Oh, and you're not going to go and do the thing that you usually do that makes it look terrible, are you? Really? Forget it. Okay, never mind. That was a failed side trip. Certainly, I do not want you to get into the habit of just clicking the red errors to make the problem go away. And I'll give you an example. When I typed scanner, because I didn't have the import for the scanner, it put a red dot on it. Over here, where it was. I go, I can fix that. Add import for java.util.scanner. Yay, I'm done. But what happens is that people get in the habit of doing that. So if they make some other mistake, like they spell scanner like that, I go, oh, red error, I've done this a lot, I'm going to just choose the top one. I could even read it. All of a sudden, we've done something really stupid. We have created a brand new class in our project called scanner. And if we come back over here, and oh man, it's still got a red dot. Well, I'm going to do that again. And then we don't know that in the background, it's adding all sorts of nasty code. And the reason for that is, I'm going to misspell it even worse, is that choice is not add import, it's create class. So if you ever go over here to hit the arrow, the red light, in order to import a class that you think exists, like scanner, but add import is not there and it says create class instead, unless you really mean to create the class, don't choose that. And if you're creating a scanner, you're not making your own scanner. You don't know how to make your own scanner. You want to use their class. Does that make sense? Don't just blindly run over here and click that in a thing in a hope of making errors go away. It may sound like I'm harping on something silly, but I swear people do start doing that, and then I come over there, and they have like 3 or 4 files over here in their directory, which they've created by, making typos and then correcting them by clicking on the red dot. So the string basics. We pretty much have already seen how this works. String S1. We have declared a string. It doesn't contain any data. It's just an empty reference. It actually contains the value null, which is a number 0 in it. String S2 is equal to the string, and I say hello. We set S1 to goodbye. So right now, S1 contains goodbye, and S2 says, and I say hello. And you Beatles fans know where we're going with this. String 1 now says, you say goodbye, because it's added that to it, it's appended it to it. So you say goodbye, and then we append to that string a comma, and then string S2, which says, and I say hello, and then a period. And then it finally prints all that out, and so the string contains the words, you say goodbye, and I say hello, followed by a period. So this is an important thing to notice, that plus equals. I think I already mentioned that. Notice that you use that to build strings as well as to add on to numbers. If I do this, int x, x plus equals 10. Well, first I'm going to give it the value of 0. X plus equals 10. Now it equals 10. X plus equals 20. What does it equal now? It equals 30, because plus equal took the value 20, added it onto x, and then stored it back into x. And then if I say x plus equals 40, that adds 40 to the value of x and stores it back into x. So this is short form for saying x is equal to x plus 40. And I'm sure that I've said that. Make me feel good and say that I have. Yay, okay. And this is short form for saying x is equal to x plus 20. This is short form for saying x is equal to x plus 10. And if you're just adding 1 to it, there's an even shorter form. If you're saying x is equal to x plus 1, you can do this, x plus equals 1, or you could do x plus plus. Use the increment operator. All three of these do the same thing. So now that we have a string, well, let's declare a string. String s is equal to there. Now let's add something onto it. S plus equals hello backslash n. It's complaining because we already had a string named s. And then s plus equals goodbye backslash n. And then we print out s. What is that going to print? Yeah, it's going to print hello, and it's going to go to the next line and print goodbye and go to the next line. Like that. And that's concatenation, because anytime you use the plus sign with a string as one of the operands, it performs concatenation, which is appending two things to each other, rather than doing math. And again, that can get you into trouble, because if we do this, my favorite numbers are, and you do 2 plus 4, it's not going to print out my favorite numbers are 2 plus 4. It's going to print out my favorite numbers are 6. No, it's not. It's going to print out 24. Right. I need to take that stuff out. Okay, and it prints 24. Why? Because it's adding it to a string. One of the operands of the plus sign is a string, so it starts converting all the other ones to strings as well. And a string 2 plus a string 4 does not equal 6, it equals 24. Just as much as if we did this. String methods. There are several methods. There are actually dozens of methods in the string class, but some of them are very important to us. Char at is one of them. I think I'm going to scroll back up to the top, and we're going to start putting stuff up here. So we're going to declare a string called college. And we're going to say college is equal to Rose State. And then we do system.out.println college dot the character at position 0. I really want my scanner though so that I can embed some pauses. And what I mean by that is I just want to do this. System.out.print, press enter to continue. And then call sc.next. Okay. That way I can have all the rest of my code down there, but it won't actually run. R. Why did this print an R? Because R is the first character. It's the character at position 0. And I've said this before, but computers start counting at 0. So that's position 0. That makes that character 1. That makes that character 2. That makes that character 3. And that makes that character 4. So if I want to print out A, what am I going to have to change that 0 to? Yeah, let's count it out. 0, 1, 2, 3, 4, 5, 6, well, 7, but you were eyeballing it. So now that if I change that to 7, it's going to print an A. And there we go, A. We can print them all out in a row. 0 is going to be what? When it runs, what is character 0? R. And then we are going to have character 1 is a O. Yeah, the pattern becomes really clear. And so on. I'm not going to do any more past the space. So realistically, since these are characters, I should be putting single quotes around them. But you don't see those quotes when you're printing out. Just like you don't see what the double quotes when you print something out that's inside double quotes. So that's one method that's part of the string class, char at. There's another one, the length of the string. Let's find out how long that string is. If we look at it, it's 10 characters long. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. System.out.println. Let's go ahead and print the word college is how long? Question mark. And then we're going to print that number on the next line. System.out. Or on the same line, but it's going to go to the next one. Print line college dot length. There we go. So that should print 10. Row state is how long? 10. And that's true. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So here's a little bit of a riddle. Not much of a riddle. But what is the last addressable character in the string row state? How large could I make that value and not get an error? Because if I make that number too large, it makes an error. Like if I change that to a 17, there's no 17th character in that string. It's reading past the end of the string. So if I try to run it now that I've done that 17, it's going to go kablooey. Here we go. The error is string index out of bounds. Out of bounds meaning that we went too far. What do we think too far is on this string? The string is 10 characters long. If we make this 9, let's do that. The 9th character is E. So anything after 9 will give us an error. So if we try to print out 10, we're going to get our exception again. and it blows up. So, how come if I print out the length as 10, trying to access char at 10 gives me an error? Why wouldn't that be the last character? And it's not really meant to be a trick question.
The method.length is set up to account for the indexing.
Right. It's because a string of length 0 would not have any characters in it. But char at starts counting at 0 rather than 1. So 10 characters is 0 through 9, not 1 through 10. I hope that's clear, because as we use arrays and strings and all sorts of other lists, we always start counting at 0, and we go to length minus 1, or you could say n minus 1, where if n it represents the length of the string, then you can access characters 0 up to n minus 1. So if we didn't know how long this string was, we could still get the last character by doing something like this. Int last pause is equal to, let's get the length of the string, college.length, but then let's subtract 1 from it. And then we could print out the character at that position. And there we go. So 0 up to n minus 1, 0 up to length minus 1. Those are the index values that are possible. Why are they called index? They're just indexing the string. That's the first index position. That's the second, the third, all the way out to the end of the string. Since we're using a calculated value here, we could change the string and it's still not going to generate an error. The code is pretty safe. Now the string length is 29, but it still printed the last character. Right there. Let's make it more clear. It was E last time. Now the last character is going to be an exclamation mark, and since the string is 30 in length, then what is the index value of that exclamation mark? Length minus 1, so it'd be 29. Right, exactly. So we've seen char at and we've seen length. There's another one, index of. Suppose we're curious about where the word awesome begins in this string. Well, it's at -1. That's not what I expected, but if you ogle the code, maybe you'll see. -1 means that string was not found in the larger string. It didn't find the word awesome in college. And why is that?
Because it starts with a capital A.
Capital A. So I have to come back up here and I have to make this a capital A. Then it'll find it. And it found it at position 22. And if we wanted to double check it, that'd be a correct. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. What if we just wanted that position of that exclamation mark that we printed? Well, we already decided it's probably at index position 29, but this will prove it. Yeah, 29. So index of searches the string for the occurrence of the string that you're passing it. And why do you care about stuff like that? Well, what if you have to parse the data? Meaning somebody's typed in a long string of data, but you need to do things with it, like you need to process one word at a time. Or what if you're afraid that they typed in 1 million with commas and you need to remove those commas? You can use index of to find those commas. And then there's even a way to remove them once you find them. So index of lets you find whether that exists in the string or not. It returns a -1 if that string doesn't exist. If that substring doesn't exist. So, tacking on stuff down here, string methods. Let's do string n is equal to Joseph, char c1 is equal to n dot char at 0. So what is c1 equal to? J. Yeah. Char c1 is equal to n dot char at, okay, let's just print out the length of it. Int L is equal to n dot length. The length of that should be 6 if my eyes are correct. So char c2 is equal to n dot char at 6. What's that going to be? It's an error, right. Exception error. Passed index out of bounds. So C2 is equal to n dot char at 5 is our P. Is our H. Thanks. Alrighty. So we've seen char at, we've seen length, we've seen index of. There's also last index of, because what if we had more than one space? If I set this string, yeah, let's just do that. N is equal to Joe, Bob, Billy, Bub. And then I do int I is equal to n dot index of space. It finds the first space. What is the index value of the first space? It's not 0, not 1, not 2, it's 3. But say you wanted to find that one. Then you could do I is equal to n dot last index of. And it'll find whatever position that is. I'll have to count it out. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So string length returns the length of the string. Really, that's all they talk about? Here I went nuts telling us about methods of the string class and they only mention length? Okay. The scanner class. We have used the scanner class already. The scanner class has some methods that are important to us. It's got a lot of methods, actually. Next int, next long, next float, next double, next byte. There's probably even a next bool. And then there's just next. This gets the next string. And then there's another version of that called next line, which gets an entire line. What's the difference between next and next line? If you use next, it only gets the next word. But if you use next line, it gets the entire line. And I'll show you what I mean. I'm going to come up here. And where we said press any key to continue, instead we're going to say enter your full name. So now we're going to do string full name is equal to sc.next. And we're going to print it out. Full name equals plus full name. And then sc.next again just to force it to pause. You would not put a pause in your real-life program without telling the user what it was doing. Enter your full name. Okay. Bobby Bob. And it says that my full name is Bobby. But it's not. I type Bobby Bob. The reason why is that .next only got the first string. It tokenizes the input. Tokenizing the input means that it strips out the white space and finds the first non-white space, the first thing that doesn't involve tabs or the return key or the space bar, and stores that. But if we want the entire line of data, we would do that. Next line. Now when we run it, it says enter your full name. My name is Bobby Bob. And it prints that my full name is Bobby Bob. So it read to the end of the line. It did not tokenize the input. Now the weird thing about next line is that it messes with the input buffer so that the next call, I'm not going to even go there right now. Just remember that you can use next line to pull an entire piece of data, an entire line, whereas next int, next float, next long, next double only read in individual pieces of data.
In the case of next, does anything after that initial space just get thrown out?
Nope, it's sitting there waiting to be read in the next time. So let's change this again. We're going to come up here and do this. Please enter two ints. So int x1 is equal to string s1 is equal to sc.next. And then string s2 is equal to sc.next. So s1 equals plus s1 and s2 equals s2. So please enter two ints. I typed something. Doesn't actually have to be an int because I'm storing it in a string, but I'm going to obey what it's saying. One. Dadgum program, what's it doing? Oh yeah, it wanted a second int. Okay, so I typed that in and we're good to go. But what if I typed in more than 2 bits of data? Please enter 2 ints. Well, that third number that I typed in is saved in the buffer and ready for the next call to .next. So here I'm going to do system.out.println, enter your name, and we're going to read our name in. And then we're going to print our name out, and I realize I made an error. You're trying to make me talk so long about this topic that I don't get to assign homework. I'm on to you. Okay. So please type 2 ints. 1, 2, 3. Wow. Why did it go so far? Because I typed in 3 bits of data. So not only did it store 1 and 2, then it printed out enter your name. It gave me the chance to type it in, but nope, too late. There was already data waiting for it. It's like you threw 3 spoonfuls of food at your baby. He ate 2 of them, and then his mouth opened back up and ate the 3rd one. I don't know. That's a really stupid simile. But you saw what happened. Name wound up containing the 3rd number that they typed. It filled in the buffer there. Okay. Let us see if we have a homework assignment that is appropriate without further ado. What is homework 3A? When I say further ado, I mean that we've already learned enough that I can assign it and make it due next Thursday. Okay, write a program that prompts the user for 3 values: the height, the width, and the depth of a 3D box. Then ask the user what they want to know about the box. 1 for volume, 2 for surface area, or -1 to quit. Then calculate what the user wants. If they typed in a 1, you print the volume. If they type in a 2, then you print the surface area. If they type in a -1, you're not supposed to do anything. The program should loop until they type -1. And then part B. The program should prompt the user for the radius of a sphere. I'm going to go ahead and upload this, but I'm not going to make it due next Thursday. I'm going to make it due the Tuesday after that. So you can go ahead and start working on it. Please do. You probably know enough to do this, but we haven't done an in-class example that quite covers this, I don't think. Does that seem fair?
Yeah.
Or can you say, oh yeah, I can knock this out in 2 minutes? Yeah, you could. You're looking at this, but going, yeah, I can do it.
If it wasn't for the loop.
Yeah.
Yeah.
Okay, so I'm going to go ahead and assign it, but let's assume that we will do some in-class assignments on Tuesday that bulk up our knowledge about how to accomplish this. And if you don't need to wait, that's totally awesome.
Yeah, loops weren't such a pain with sectional values.
Mm-hmm. All right, it's there. Looks like we may not have gotten everybody's submitting something for 2B. Work on it over the weekend, and if you're stuck, send me text. I'm really easy to get along with. Take pictures of your code, send it to me. I can usually answer you within a few minutes unless I'm driving. If I'm driving, I'm not going to look at my phone and answer you. But so hopefully you can get it done. Just remember that you can still make an A on an assignment as long as you get it done within a week of the due date.